In this problem, we are being asked to compute the present value of each of these two plans separately and figure out which one would be a better choice, purely from the result of the present value calculation, because as you can imagine, there are other factors you might want to consider, but at this point in this problem, it only is based on the PV calculation. Under Plan A, you're being given $55,000 each year for the next 6 years. So at the end of year 1, you're given $55,000. End of year 2, another $55,000. Year 3, another $55,000, and so on for 6 years. Under Plan B, you're being given $525,000 once at the end of the 6th year. In each case, the interest used for this calculation will be 14%. Now, given that information, here's the answer. And later I'll explain a few things from here. Talking about Plan B first makes it easier because really, if you look at down here, I already have set up a timeline. I always do a timeline for any of these things, and so under Plan B, you're being given a total of $525 at the end of this year. And so, what is the actual present value? What is the value in present value terms right here? So you're going to have to figure, in your head, at least conceptually think about it. You're going to be getting $525,000 here at the end of year 6. But what is the actual value of that amount right there? So you have to do that present value calculation, and you can do it doing it this way. With respect to this Plan A, it is a similar approach, but now you're looking at not just one single cash flow, but actually 6 of them. One happens here at the end of year 1. So you get $55,000 here at the end of this year. You get $55,000 here at the end of the 2nd year, and so on. So you get actually 6 of these $55,000 amounts. So if you actually do the math, you see that you get something like 55,000 times 6. It will be $330,000 worth of cash. So very, very much below this 525. Now notice that the actual answer is much closer than you might think. Well, that's because of the time value of money. How that works is kind of interesting. Notice that with respect to the calculation, all right, and I'll show you later more detail about how this works. But for now, look at what's going on here. You're simply taking the cash flow and applying something called a PV factor. In this case, is a PV factor of a single amount, denoted by a dollar sign like that. And so you can either get this 0.456 from a table, and I'll show you in a different lesson how to do that, or you can use this simplified formula to get to this number. So you say 1 over 1 plus, what's the R in this case? The interest rate will be 14% as given up top. The T will be time, so it will be how many periods? 6 of them, right? So 1 over 1 plus 0.14 to the 6th. If you do the calculation, that gives you this PV factor. So you multiply that PV factor of a single amount times the amount, the cash flow, and that gives you a PV for this amount of 239. So these two are equivalent. 525 is at year 6. 239, 183 is at year 0, basically, at now. A similar calculation is done for Plan A. But in this case, you're looking at not just one, but a series of cash flows, which is, that's when you call this an annuity. An annuity is a set of cash flows of the same amount over the same interval. So you're talking about 55,000 6 times. Now, again, you can use a table for PV of an annuity, or you can use this formula here. And if you use the formula, you need to make sure that you use the brackets correctly here. 1 over 0.14 minus 1 over 0.14 times 1 plus 0.14 to the 6. If you do that, you end up with the same number here. And now, this will be more accurate than this. It will be to many more decimal places. So for now, we're just going to use the table number that is rounded to the nearest hundredth or thousandth, I guess. And so you multiply this PV factor of annuity times the cash flow, the single, the cash flow, $55,000, and that gives you an amount of 213 now, 8877. So this obviously is less than the 239. So that's really what you do for present value. Now, conceptually, this is what's happening here. Yes, again, it's the same thing I just talked about, but it just breaks it out into parts. It's a lot more detail than you really need for this problem. But again, here's the cash flow number 1, cash flow number 2, and so on up to cash flow number 6. Each individual cash flow, you can actually use a formula to come up with a PV factor, which if you add them up together, you end up with that factor that I just showed you up there, and you end up with the same amount. And so you can study that table if you wish in your notes once you download this Excel spreadsheet if you want to.